Now we come to the last presentation, but still very important before the break. In Europe, it's lunch break, but it's a very quick lunch now. And I'd like to welcome the speaker. It is Mr. Henneken from Jowat company. Jowat company is a very well-known, worldwide known glue manufacturer, not only for wood gluing, but also for other materials, including a processing plant in Malaysia. And Mr. Henneken is head of the R&D department within Jowat company. And Mr. Henneken, or Jowat, Mr. Henneken in person, this member was and is member of Palmwood.net. And Mr. Henneken has taken a big load because he did all the administrative work for Palmwood.net for many years. And now he is going to explain us a very important thing. We have seen very many glued products, and for the gluing, it's also a new field because of the structure, but Mr. Henneken has the solution for it. Mr. Henneken, the floor is yours, please.
So thank you, Professor Frühwald. Hello, everybody. So I try to hurry up, and I'm not sure if I can pick up some time. I try to share my screen. Let's see if you...
If you can do, you get an extra lolly, Mr. Henneken.
Can you see something? No?
Not your presentation, actually.
It's a little strange.
Try to share that.
Yes, I'm trying, going on sharing screen.
Yeah, they have the options there. In the Zoom, you can go down. There is the option to share a screen.
Yes.
You can click on that.
Now I can. Yes, I wasn't able before. So let's see if I did share the right screen. What?
Perfect. Enlarge, and then you start.
So can you see the first slide?
Yes.
Yes.
Okay, perfect. So I'm pleased to tell you something about gluing of OPT composites. Just a very short word about my company. So Jowat SE is a global manufacturer of adhesives. We have 1,200 employees. We're operating worldwide, and hold on a second, I have to remove the pictures of the presenters. So, okay. So we're operating worldwide. Here you see a picture of our production and R&D centers. On the right bottom, maybe interesting for you, it's close to KL, it's close to Sepang International Circuit, close to the international airport. This is our production site in Banda Aceh in Malaysia, where also many of the work which is presented now has been done. This is an image of what our adhesives look like. We have 650 different products, not so important now. Now jumping into the important topics. So you have seen this already in the previous presentations. Just want to mention here the black highlighted parts, edge banding and gluing, pressing. This is the part we have been working on in the project. This is also familiar to you. Mr. Kisselbach said it's wires in a sponge. That is actually his wording, so I copied that here, cited it here. This makes it for us quite special. It makes it different from other wood species. Also, the pressing mentioned here, it should be sufficient pressure, but not too much, especially when you're going to low density materials. Too high pressure can make damage. You've seen the products already. So to make these products, we have shipped OPT, kiln dried OPT from Malaysia, luckily before Corona, from Malaysia to our plant in Detmold, East Westphalia in Germany. There we did some resorting into density classes, restacking, and shipped it then further to a school of carpenters, and they made the first products to be displayed on the Ligna Fair for us. You see some impressions of these gluing steps. So it's they use the PVAC dispersion here. They use doctor blades to apply the correct amount. They had to work very quickly and did it all in parallel because of the short open times and the large areas here. But it worked out fine, and we got these products you have seen before. Also, when producing CRT panels, in this case is pictures from production at Minda. Our adhesive, in this case, not a PVAC dispersion, it's here, it's a polyurethane prepolymer applied at room temperature. It is applied with this semi-automated, so it's yeah, several lines, beads are produced there in parallel, but it's a slow process. So if you do it like this in manual, you have to really hurry up that the adhesive is not hardening and drying too quick before you can arrange the top layers. So this is for industrial scale, you have to go on other machines that are quicker. And here you see such a trial. We did it at a flooring production plant. We rented the machines there. You see a roller coater here in black. There, the adhesive will be applied to the boards. So the boards, we have prefabricated side-glued lamellas. And these layers have been transported here automatically, then coming here, then to the roller coater. And from the roller coater, when the adhesive is applied, it goes into the press, being pressed, and yeah, the final product board will be taken out later on. You will see pictures. Here you see a picture of the roller coater applying the PVAC dispersion. I've chosen this picture because it shows already a problem. If the lamellas are not perfectly plain and at the same height, same thickness, this happens here. You can see there's a different height. You can also see it here that this lamella has less glue on it, and here this is a little higher. There was a lot of pressure on it, and the side gluing was breaking up. So it's very important to have evenly distributed lamellas of equal thickness. Otherwise, these processes could fail. But as you see, it was possible. So if the adhesive application is good, one has to be really quick. Normally, we would stay in this fully automated process and automatically apply the top layers. Here, we had to do this manually and put the second layer on there and put it back on the belt to go to the press. You see an example where a veneer, a mahogany veneer, was used as top layer, put there on the bottom layer with the adhesive on there, went into the press, and the board is afterwards removed then there for testing and further processing. So coming to the adhesive performance. So I can only give you a very short input into all these topics because of time constraints. I could talk like 45 minutes or 60 minutes on these topics. So I'm talking about penetration behavior, showing some microscopy images. I'm saying something about surface treatment to strengthen the wood structure, especially the parenchyma. Then we do comparisons of different adhesives. And also Mr. Kisselbach talked about the edge banding. I'm showing a little bit about this. So the penetration behavior, I mean, it seems clear that you have this soft parenchyma, that penetration is happening there. But actually, if you're looking into the pictures, it is true. You have quite some penetration here in the parenchyma, but a lot happens also through the vascular bundles. So the adhesive is applied with pressure and is going through the bundles and is released inside the material somewhere. So we have a network of adhesive in the material. As you can see a cross section here where a vascular bundle has been cut and it's filled with adhesive. What you see also, so the upper images are prepolymer adhesives, isocyanate-based prepolymer adhesives. The bottom part is PVAC dispersions. And this is typical. The dispersions are actually not penetrating that deep into the parenchyma. They are penetrating quite a bit into the vascular bundles, but not really in the parenchyma because of the viscosity of the material. And also, if the viscosity is reduced a lot, still these polyurethane adhesives are penetrating more. We try to plot this. It's difficult to really have it quantified because it's quite a subjective impression always. But you can see the also for 80 grams, for 150 grams, and for 220 grams application amount, it's always the prepolymer adhesive that is penetrating deeper into the material, and then the PVAC dispersion and the EPI. But from subjective impressions, EPI is penetrating more actually also. So here's another picture of the cross section that shows it could also, these are samples made by the Schröder splitting saw that Mr. Kisselbach has presented. They are 6 millimeters in thickness, so you can see it's penetrating all the way to the 6 millimeters. So it's quite deep. It's much more than with other wood, such as beechwood, for example. So here I've said I'm talking about this treatment to strengthen the material. We call it après-tour treatment. It's a polyurethane material, very, very low viscous. It can go with a vacuum, it can be sucked into the material and strengthen it a lot. What we did actually, we applied it also just a little amount with a roller and did adhesive tests with that as well. You can see it here. Adhesive testing that we're doing, tensile testing. The green is they treated with the après-tour. It's only green to visualize. So normally it's not colored, but we made it green to visualize. We prepared the samples for 5 centimeters times 2 centimeters for overlapping adhesive bonding, and they were sorted to density classes. Then we did the measurements, and these are the results. I put them all in one table. We have many, many, many more, but just a short glimpse to understand for you. It is in white, it is the standard with no pre-treatment. In red, we did a pre-treatment, dried the samples, and then did the adhesive on application and the gluing. And in black, it is pre-treatment and immediate, so wet in wet, immediate bonding. And then after 1 week, final strength of the material, 1 week in the climate chamber at 25 degrees, we did the measurements. And you can see that dispersions are at a, never mind what dispersions, if it's a 1K, a D4 dispersion or D3 dispersion, they're always in the range. Also EPI always in the range of 800 to 1000 Newton, which is with the area about 5 megapascal. With the hydrophobization, so the après-tour, you can boost it up to 8 to almost 10 megapascal, which is very, very high. So it's almost close to hardwood. So if you know how to do it, you can really get very, very strong forces. But for flat lamination, you do not need these high forces. So this 5 megapascal is fully sufficient. But generally, as with other woods, the prepolymer adhesives are the higher quality adhesives and give also, in general, the best results with OPT. Edge bending. You see the edge bending machine in our technical center here. And also the tests we did there. There we did no shear testing. We did a peel test, 90 degrees peel test, pulling the edge of the OPT. We used different boards. You can see it here on this example. We have parallel to the fibers on the outside and perpendicular to the fibers in the inside. And you see the image on the picture. You see the vascular bundles actually, you can see them on the adhesive when it's pulled out. And if you're pulling parallel, you're pulling out a lot of more fibers. But what does it mean to the strength? We tested it with the EVA hot melt and the polyurethane hot melt edge bending adhesives. And the polyurethane was always about twice as strong as the EVA. Both were okay. So it was no problem with the strength, a little lower limit than with the, for example, particle board, but still very good results. Here you see pictures. Actually, these are two pictures, two sets with the polyurethane hot melt. You can see here you have a strength of almost 80 Newton per centimeter if the arrangement is perpendicular. So you're gluing the end grain, actually. You're gluing on the cross section of the vascular bundles. So you have higher forces here. Here you have much more fiber here, but it's okay, but it's much lower forces associated with this. So coming to my conclusions, generally, all adhesive technologies actually that are used for conventional wood should actually be suitable for OPT, as well as it is chemically a similar material. And this is actually the case. So if you're really modifying conventional adhesives, you can make them fit for purpose, actually, to be very well suited for OPT gluing. So we have tested PVIC, EPI, polyurethane, one component, moisture curing prepolymers, polyurethane hot melts, and EVA hot melts. And even though failure mode is always wood failure, I mean, the wood is really, it is known that the wood is less strong, at least with medium densities, but also parts with the higher densities, less strong than, for example, beech wood. But even though you have always wood failure, you can choose adhesives that have this wood failure at much better bond strength than with other adhesives. So you need to choose the right adhesive for the right performance, for the right product you want to make. As almost always, the polyurethane prepolymer adhesives and also PUR hot melt adhesives have shown best results, but PVIC dispersions can be made suitable as well. And you've seen we produced composite boards manually and semi-automatically, and you've learned today we're going to sell our technology for fully industrial processes very soon to be seen on the market. So this is my presentation. Thank you for your attention, and I'm happy to answer any questions if there are some.
Thank you, Mr. Henneken. Thank you very much for the insight.
We have no questions in the chat room, but if anybody asks, we are already getting late, but if somebody asks one or two questions, we can take it.
Yeah, okay.
Anybody have any question, please ask that. Otherwise, we are going to the coffee break, and then we have the keynote 2 after this.
Okay, thank you again. Thank all the presenters for this session. And so far as I see, we have 10 minutes coffee break for those who like to listen to the second keynote. Starts at in about 10 minutes, not 20 minutes. About 10
minutes, because we already late. Other room already finished. So this room A, you just stay because the keynote is going to in this room number A. B and C will join in this. So Just it's a 10-minute, but we are not going to what we call the disconnect it. Just stay on this. Okay.
Okay.
And then if you want to take time, 10 minutes, and then we can start again on this. Thank you.
Okay. Thank you.